Okay, are you still able to see my screen?
Yes.
Okay, great. So, hello everyone. Thank you for joining us today. We're going to be going over kind of getting started with NCL, and this is the second part of our two-part series. So, last time we previously went over some basics of um, getting into open source intelligence, getting into um, log analysis, and also getting into cryptography. And so we're going to go a little bit further down this path. I think today we're going to cover a little bit more of like more technical things like looking at network traffic, as well as using the Linux command line. A lot of NCL challenges will feature an actual real world environment where you actually be able to get a real Linux command line and run real commands. So it's useful to learn those basic skills. Um, as a reminder, NCL is it's a competition, it's a learning experience, it's a game. You're not expected to know everything going into it, and we're trying to help you develop those skills of how do I learn things on the fly, how do I, when I get stuck, use online resources and use the resources that are at your disposal to um, to actually understand what you need to learn in a short period of time to move forward. Just like in the real world, you're going to be in a situation where you have to interact with some new technology, some new software, and you don't have very much time. You don't have the opportunity to take a course on it. You have to learn it on the fly and make do. So with that, I'm going to go into our network traffic analysis section. Um, so this section is all about having people read through packet captures, which are basically just the saves of data of communication across the network. And we actually provide, I'm going to zoom in a little bit. We actually provide a packet capture as available as a download, so people can go and download the packet capture. The common tool to use is Wireshark. So if you have your own installation of Wireshark on Kali Linux or on your on another operating system, you can download that file up, load it um, into Wireshark, and you can follow along there. There's a lot more capabilities with Wireshark than there are in the cloud version that we provide here with CloudShark. But when you go through some of the more beginner challenges, you can actually solve a lot of the stuff directly within CloudShark without needing Wireshark. This challenge is FTP traffic, and so if you don't understand what FTP traffic that's probably a good place to get started with your Google searching. So go and look up Wikipedia. I'm sure there's a bunch of different articles about what FTP is, but FTP stands for File Transfer Protocol, and so this is you know not so common now, but was much more common back in the earlier days of the internet to transfer files from one computer to another. You'd have a server that's hosting some files, and then a client will connect to that server and download the files or upload some new files. And we have a packet capture here of an interaction between a server and a client going through FTP. Now, the very first question that we have here is, what is the first username and password combination attempt made to log into the server? And when you look over, what you'll see is individual packets. So each of these packets, each of these lines is a piece of information that's being sent from one device to another device. You can imagine these as kind of like pieces of mail. The mail kind of comes in, you chunk them into pieces, and you send it over. Um, and you can actually use some built-in tools to process this information. On the bottom left here, you can see that there's information about this packet, and so Wireshark and CloudShark have what are called dissectors, which is basically you are looking at the actual packet on the right side here. It's just raw data being represented as hexadecimal here. And this data, you need instructions to be able to interpret this data and understand this data. And what is happening on this left side is that it's following instructions to make sense of that data. And you can see here that when I click on different sections, the highlighting changes and it tells me what that corresponds to. And so there are several protocols. And if you're not familiar with the TCP/IP stack, that's a great place to go. But TCP/IP basically is a common protocol that's being used to basically define how do I transfer data from one computer to another. And that's where you see the concept of IP addresses showing up. An IP address is a way to reference a device, and it's imagine that as a mailing address. You can go and mail something there, and all of these different fields here are part of that IP wrapper that basically, imagine this as the you sign a letter, you have a piece of mail, you're going to put the to and the from on that mail. And so this information up here is basically that to and the from. You have the source and you have the destination. And so you can see where the data is going to and where it's coming from. In this example, we actually have data where it's coming from and going to the same address. I suppose you could do this in the mail. You could drop a letter off that has the same source and destination, and then it'll get rerouted back to you. And there's a second part on here, which is source port and destination port. So ports, you can imagine this if you have like an apartment building. These are basically the different unit numbers. And so the address is what is representing that building, making sure that information can come to the building. And then once you get to the building, you need to figure out which unit that's going to go to. And that's what these source ports and these destination ports are. And the ports are going to be tied to a specific program. And so for FTP, FTP listens on port 21. And so if you have a package coming and you have a packet coming in destined to your address, your computer, and you have an FTP server that's running, by default, it listens on port 2021. It will pick up that data, and then the data will be sent to the program for processing. There's this destination port, and you can see it's a much larger number. This is an ephemeral port, which is basically just a temporary port that's being used for the purposes of this communication. And so what we're actually seeing is data that is coming from port 21, which is an FTP server, and it's going to this ephemeral port on port 53233. And if we actually go and look deeper, there is additional information about FTP below. And so this top part, this is specifically the TCP/IP section. And if I highlight it, you can see that this entire section is TCP/IP. This is just a section of the letter that's saying where's it coming from, where's it going to. And then after that section, we actually have the message itself. And so this is containing FTP data. And so if I go click into these sections, you can see that's highlighting. And the FTP server says, hey, this is my version number. This is information about who my creator is. Visit this page for more information about the server. And so this is a banner. So when you connect to the FTP server, it's going to send this type of response back to basically just say, welcome, thanks for connecting to my service. This section for FTP, there's a specific specification that defines how to convert these binary data, in this case, it's represented as hexadecimal, how to convert this information into this text. And in other parts of the protocol, it might have like a status code. And so you can see there's a status code 220. All of that is defined by a specification, and that specification is different depending on the protocol. And so we're looking right now at the FTP protocol. If you were to look at a different protocol, people are probably familiar with HTTP or HTTPS. That's the protocol that you use to visit websites. There's a completely different specification and set of instructions in terms of how do I convert this data into something that's usable by my program and usable to the end user. So that's basically like what this data is in a nutshell. Thankfully, we have tools like Wireshark and CloudShark, so you manually don't have to go and like interpret what is 46, 69, 6C, 65 mean. That's being done for you and automatically processed, and then you can see, okay, it means FileZilla server, whatever, whatever, whatever. And so all that's done for you. And so it appears that basically what has happened is prior to this capture starting, someone requested to connect to this FTP server. That happened before. And then when we start, the first thing that happens is that the server is responding back to that user. Oh, sorry, I'm clicking on the answers right now. And so I'm going back to now to the very first question. I just explained kind of what is it that we're looking at here, and we're going back to this question, which is asking, what is the first username and password combination attempt made to log into the server? And thankfully, we have some tools here. So if you're just playing around, you could click and eventually find it. So I click on this request user, and you could probably just guess that user password. That looks like a user and password combination. Password required, login password incorrect. And we're actually looking for what is the first one to be attempted. So that's actually what we're going to put in. I'll just put in user one, password is Cyber Skyline. And we've got that first question answered. And then the second one is asking for what the version of the software is. So actually we go back here and we previously saw this, that there's a FileZilla server listed here. And that's what we're going to try. And so the thing I want to highlight here is that if you're coming at this for the first time, what you're typically doing is you are, oh, I spelled it wrong. You are typically just kind of, it's like a scavenger hunt. You're kind of just looking for things. FileZilla. I'm having a hard time speaking and typing at the, okay. We're gonna, can I copy and paste this? There we go. Did I miss something? 0935. I got this backwards. 53. There we go. Okay. Yeah, it's difficult to speak and to type at the same time. And if you have any questions in the chat, please let me know. I actually managed to get the window open, so I'll answer them as they come in if there's any clarification that's needed. But what I wanted to highlight is that if you're going through this for the first time, you might not know for certain that you got the correct answer, but we give you plenty of attempts. I mean, you can see here we have 35 attempts and there's like maybe 7 questions left. There's 6 questions left. You get plenty of attempts, you get plenty of chances to, guess around and see if you can get to the right answer. You're mainly doing some kind of like pattern recognition and trying to use context clues to get to the right answer. And so if you get a question that's asking what software is the FTP server running, and you don't know that FileZilla is an FTP server, but you see the word server show up and you're like, oh, well, they're asking for an FTP server. I wonder if that is the FTP server. And then you have this, which looks like a version number. You go and type that in, you get that confirmation. You got that without actually definitively knowing that is the server, and you did that pattern recognition and the context clues to get to that answer. And that's perfectly fine. That happens a lot for beginners, and that's kind of how you're learning. Because in the future, now that you know, okay, so when you have an FTP connection here, one of the first things that it does is it says the server version. And so in the future, if it's not FileZilla, it's something else, you'll be able to understand that and pick that up. So it's about following the breadcrumbs, trying to gain that gem of knowledge from answering each question. Okay, we're going to move on to the third question, which is asking for the username password combination that allows for successful authentication. And so if we go back in here and we just look, it says we put in this username, we put in this password, it responds saying the login password is incorrect, and then the disconnect says goodbye. Okay, so we make another connection, and then we can see here that we try the same user, but we tried a different password and now it says logged on. And so considering that it previously said the login password was incorrect, now it's saying logged on, I think that's going to be the correct answer now. And so I'll come here, user one, that's the new password. And we've got that correct. We're moving on to the next question. It's asking what is the first command that the user executes on the FTP server. And so you can see here, there's this thing that says port command successful. And what I'm actually going to do is, because we're starting to get a little bit further on, if you play around and you can search for like, additional like tips and tricks on how to use like Wireshark and CloudShark. A common thing that you'll find with Wireshark is the ability to follow stream. And the way that you do that in CloudShark is actually come up here to analysis tools, and then there's this button here. And you can see that this interaction here summed up for you, so you don't have to parse through each one individually. It makes it a lot easier to see. So I'm gonna go through and try to answer this question. And so you can see here we have that banner, we have the login, it says logged in, and then it says port, and then it has all of these things behind it. And so I'll type in port and give that a shot. And it actually got marked as incorrect. And this is expected. So this is more of a nuance with the protocol for FTP, and this is an error that I would expect a beginner to make. But if you basically go and you Google and you try to research more about like what is this port command, this is something that happens automatically when you connect. Like this isn't something that you type in as the user. When you connect to the server, your client will automatically send this command over. And so this is, if you go look at the prompt and figure out what is the command that the user executes, the user didn't actually execute that command. That's being automatically done. What they actually did was subsequently typed in the list command, and then to get a listing of all the files in the folder. And so I can go here and I can type in list. But if you just kind of do trial and error, you tried this one, it didn't work. You try this one, that one did work. And if you actually Google around and try to figure out, well, why is that a case? You can see the history behind it and like why it works that way. And considering that this is in the practice gym for NCL, you actually are allowed to go and ask like a professor or a friend for help and assistance, try to understand like why does port not count? And it's because, okay, this is not something the user actually types in, it's an automatic thing. Moving on to the next question, we're being asked, what is the file that's being deleted? And so there's a subsequent command that says delete. Now, you could probably guess from context that this might be delete, especially when like the next thing that follows says file deleted successfully. But if you didn't know what this meant, you could actually just go and you can go on Wikipedia FTP commands. And you can search for delete. And there you go, delete is delete file. And that gives you the context to say, okay, well, this bank.cap is what got deleted. And then what file is uploaded. Again, using context clues here, you see successfully transferred compcodes.zip. I have to admit, like myself, I don't remember the FTP commands. I don't remember that delete is delete and store is like an upload command of some sort. That stuff, I think like those details are details that you don't need to memorize. Those are details that like if on the job you had to figure this out, you could search around and get to the right answer. And so you as the participant and you as the learner and as a future cybersecurity professional, your task is basically how can you leverage context clues to get to the information that you need without having to memorize literally everything under the sun, because it's just not going to be feasible. And if you can put the context clues together of, okay, it looks like there's a transfer here and it says opening data channel for file upload. I think this must be the command to do the file upload. And if you go over here and we search for upload, maybe they will just search for store, STOR. There you go. Accept the data and to store the data as a file at the server site. So that's basically an upload. And I can come here and I'm going to just type in comp codes. dot zip. And now it's asking for the file size. So this is actually a little bit more of a challenging question because there's actually no file size listed here. And so there's, actually, let me see, is there any metadata that we have here? You can tell that I haven't memorized all of these things. These are, I'm kind of figuring everything out for the, again, trying to just use kind of what I know from the pattern recognition. So we have follow stream, packet lengths, HTTP analysis, comp codes. Okay. I think there's probably a some sort of analysis tool to help with this. But what you can actually see here is that there's all this this FTP data, and it's referencing store compcodes.zip. So this is all of the data for the zip folder being split out into multiple pieces. And the reason why it's being split out into multiple pieces is because these are all different packets, and there's a maximum size for a packet. And so if your file is larger than that, you have to split it into pieces. And this is kind of why like sometimes doing the follow TCP stream is very helpful, is because like sometimes the data is too big to be shown in a single packet. And so if you do the follow TCP stream, it'll help you with that. But what I'll do is I'll try to solve this without actually using a more sophisticated analysis tool. And I can actually see, okay, it's transferring 1460 bytes at a time. And at the end, it's slightly fewer bytes. And so I'm wondering, what if I like counted how many lines there are of this, added them all up, and then added this little thing at the end. So we go from line 43 okay, so we're at 43 minus 25 plus 1. I hope I did that math right. So we have 19 times 1460. 19 times 1460. And then over here, this is plus 443. And I'm just taking a wild guess here because I'm not entirely sure if I did this correctly. Oh, I did. All right. So this is to highlight there's multiple ways of doing things. You could do it the old school way, which is like, the simple way, which is let me just look at all of this data, add all these numbers together, and get to the correct answer. I think if you use a more sophisticated tool like Wireshark, and you actually downloaded this file and looked at it in Wireshark, there are tools that'll tell you like how big that file was without you having to do the math on it. But two ways to do it. I could do it that way with Wireshark, or I can just add up all the numbers. And then we're at the final question here, which is what file does the anonymous user download? And so we need to be looking for anonymous, and there's anonymous, pass required for anonymous blank, then they logged in. And so let's follow this stream of them interacting. So there's the login anonymous. It looks like they're trying to do something with a file called security because the file is not found. They are trying to access something with bank.cap, file not found. And they're trying to get a listing. Okay. And so they're running, it says opening data channel for file download. That sounds to me like they're downloading a file, and it looks like they're downloading the compcodes.zip, which was previously uploaded earlier. So I'll type in compcodes.zip, and we've successfully completed this challenge. And so the thing I want to highlight about going through this whole process is that like not knowing how things work is part of the process. So don't feel that like if you don't understand fully how things work that like you can't do it. It's all about like, well, let me just guess around. And that's why we give you so many attempts. I mean, like I still have 28 attempts remaining. If I was making a lot more mistakes, clearly I am familiar with this challenge, so it's a little bit easier for me. But if you're more of a beginner, you have all these different attempts, you have the opportunity to make mistakes. As long as you're kind of making educated guesses, um, then you're doing it right. And every time you kind of guess towards the answer and then you finally get it marked right, you can then go and ask yourself, okay, so let me go back and confirm, why is that right? How, like, can I figure out why that answer is correct and the previous answers weren't correct? And that's how you're building that knowledge. And again, I want to emphasize, like, there isn't any purpose in me memorizing the port command, the list command, the del command, the store command, like all of those things. I can go online, I can Google and I can search it. I can get, I mean, there's this whole Wikipedia list of every single one that tells you what they do. So don't worry too much about like memorizing specific details. It's more about how can you learn to use context clues to solve a puzzle. Because chances are, like, if you do something more sophisticated and you look at a different packet capture that has FTP data, maybe we use one of these tons of different other commands that you didn't memorize the first time around. So the important part is figuring out the process and not the specific details, because the details can be found online very quickly and very easily. Um, Okay, and so that is how you can approach the network traffic analysis section. I want to go deeper into the log analysis section that we did previously. And so last time I briefly touched into just using context clues to get to the answers in some of the log analysis challenges. Sometimes you might need to do a little bit more than just reading the file. You might need to like actually parse out the file in an automated fashion because it's not feasible for you to do manual counts on things. And so we have this file here. It's not super long, but it's longer than you might want to put into your brain in one shot. It's got about, what is this? It's 99 lines. And so that's a little bit too much for you to want to manually process. And so what we're going to do is we're going to try to use a combination of different tools, especially with this Linux terminal, which I'll show how you can use Linux to help you solve some log analysis challenges. We're going to use all these tools to help us get to these answers. And so the very first question, actually, let me set the context behind this a little bit more. What we're looking at is an access log, and this is specifically an Nginx access log. And if you go on Google for Nginx, Nginx is a web server. So this is something that's going to be used to host a website. And this is a log that is storing all of the requests that have been made to get different resources on the website. And so this is people just trying to visit the website. We're being asked how many different IP addresses reach the server. And so you can see here in this, we have an IP address. There's no other IP address in each line. I think you can safely assume that this is probably formatted in this specific way so it can be understood. And so if there's only one IP address here, and we have the context that these are people who are trying to visit our website, this must be the IP address of the person requesting the web page. You could Google around to learn more about like Nginx access logs, and you can get more information there. But like, let's just make that assumption because there's no other IP address that we could possibly be referring to in the context of this question. And so there's a couple ways you can solve this. One way is, I suppose, you could manually compile, like go through all of this and copy and paste this into a separate list and then figure out how many of those are actually unique. That sounds like a very time consuming way of solving it. I would not recommend it. And that's why I would suggest maybe we use the Linux terminal a little bit to help us answer this question. And so I have a Linux terminal here, and it actually has already the access log included. And if you're not familiar with the Linux terminal at all, I'll go over some of the basics as I go through this. But basically, the Linux terminal, you can imagine it, if you've never used a terminal before, you can imagine it as like the equivalent of of what you might do with like Windows Explorer or with the Finder on Mac, or Windows File Explorer. You're probably used to looking at files through a window and you click on different files. This is a similar concept, but instead of using graphics, it's all entirely text-based. And so when I do ls, that is getting a listing of all of the things in my current folder, and I can see I have an access.log file in this folder. So this would be the equivalent of you opening Finder or you opening Windows File Explorer and seeing a single file in there called access.log. Um, Now you could double click on that access.log and it would probably get opened in some sort of file reader program. Maybe it's Notepad, maybe it's you're opening it in Microsoft Word. There's a bunch of different programs that you can use to open that file. Um, and we're a little bit more restricted in the terminal because there's no graphics, it's entirely all text. And so what I'm going to do is I'm going to run cat. Cat is the concatenate command, and what it's going to do is just going to print out the contents of the file. And if I run that on access.log, again, I want to reinforce that this is basically the equivalent of you double clicking on access.log, but instead of that opening in a program, it's just going to print out the text to the screen. And when I do that, you can see, all right, there's a lot of stuff here. It's all the same data. Um, how do I process this? How do I manage this? And so Linux is pretty cool. With the command line, what you can do is you can actually take the output of one program and then make that the input to another program. And there are a bunch of different utility tools in Linux that help you manipulate text and help you to manipulate data. And these become very handy. And so what we can actually do is when we do cat access.log, this is going to print out the file. I can use the pipe command. And what the pipe command is going to do, it's going to take the output of the left side of the pipe and make that the input of the right side of the pipe. And what I'm going to do is I'm going to pass it into the cut command. And what the cut command does is it basically helps you, if you have like column data, it lets you split on a separator and then select one column. And so what I'm actually going to do is I'm going to do cut and then -d. And so let me actually step back a little bit. When you run Linux programs, you're going to type in the name of the program, and then everything that follows that is going to be options being passed into that program. And so when I'm doing cut, I'm also providing this -d. There is a -d option, which I am enabling and setting on the cut program. And you can search online or you can pull up the manual for the cut program to figure out what all those different options are. But in this case, -d specifies the delimiter. And so that's going to be what character I want to split on. And so I'm going to say, okay, we're going to have columns, and the columns are just going to be spaces. It doesn't work so well over here because it looks like this data should be kept together because it's in quotes. But for the purposes of getting this question, I think this will work for us. So I'll do cut -d, and then what I want to do is I want to specify a field, and I'm going to specify the first field, and then let's print that out. So what that did, I'm just going to go back a little bit. What that did was it said, I want to print out this access.log file. I'm going to send that as input to the cut program. And the cut program is going to say, separate out these into different, each line, split the line into columns. And the columns are going to be separated by spaces, and then select the first -f is like the field, select the first one. So we have a space here. So this is going to be column 1. This could be column 2, this could be column 3, this could be column 4. There's a space here, this could be column 5. But we're only caring about column 1. And so all this other data is just going to get removed, and we're going to be left with only the first column, which is these IP addresses. So already we saved a lot of time because if you wanted to do that strategy of like just put it into a separate document and you manually figure out which ones are unique and not, you no longer have to worry about like accidentally selecting anything that is an IP address. That's been filtered out. But we can actually go another step further. There's another tool in Linux called sort. And as you can imagine, it's going to sort the data. So I don't think I need to elaborate on this too much. We're just going to send it to sort, and now all of our data is sorted. So all of the same IP addresses are being grouped together, which makes it a lot easier for us to process. And it becomes useful because the next thing that we're going to do is put this into a program called Unique, and that's actually spelled UNIQ. And as you can imagine, it's going to basically uniquely just print out the unique values, the unique IP addresses from that list. So we went from, a lot of these like .122s to only 1.122. So we now have a unique list of all of the IP addresses in that file. And from here, I'm going to actually chain it one more time, and I'm going to put it through a program called WC, which is word count. And then I can do -L, and that will give me specifically, let me expand this so it's not so confusing. The -L is going to specifically say, give me the line count. So WC's word count, I think if I do this without the -L, I forget what these columns are. This one's definitely the number of like words that it counted. I think it's counting each of these individual numbers as a word. But actually, we can look this up. So if you type in the man command, that says manual, and what is it going to print? It's going to print characters, lines, bytes, words. I think I'm gonna have to do a little bit more searching on this to figure that out. Not for today's, not for the purpose of today. I think that's something that needs to be done at a later time. But that's basically how we're getting the line count here. And so we have 47. I can go in here. I can type in 47, and that gets marked as correct. And so without actually having to painstakingly copy and paste every single one of these lines, we were able to get to the correct answer relatively quickly. And definitely, I think this is more interesting than the manual labor of copying and pasting all of the texts and then manually trying to make sure that you don't have any duplicates. That's much more prone to error as well. And so you're probably wondering and asking yourself, like, how do you learn about like the cat command, the cut command, the sort command, the unique command, and the word count command? There are a bunch of online resources available that will teach you these things. And so if I think Linux Journey is a good place to go. And so this is a great place where they'll teach you a lot of the command line tools. And so in this section, they have like how to use cut. They cover echo, sort is in here, word count is in here, unique is in here. And so they have a ton of different little tutorials on how to use a Linux command line. I definitely suggest this resource. It's completely free, and it teaches you a lot of the basics. And so what you learn here might be very helpful for when you start using the Linux command line. But that's how you would answer this first question. I'm going to move on to the next question, which is how many requests yield a 200 status? For the purposes of this question, you don't actually need to know what a 200 status is, but if you're curious, this is all HTTP traffic. This is traffic from a website. And so the status code of your request is being logged in each of these lines. And I'm trying to see, okay, so it's here. It's what follows immediately after the URL that this section, the request that you made. So there's 404, 404. If you just do a search, so I'm just going to search for 200. I wish this would highlight it a little bit better, but you can see there's a 200 here, there's a 200 here, a bunch of 200s over here. It's in the same place all the time. It's in this basically fixed location. And so you can see that like this must be the status code of 200 because it's the only thing that's kind of consistently in this. The only place where 200 is consistently in multiple lines in the same location. And then if you also look at the subsequent question, it's asking for 400 status. you get the same thing, 400 here, 400 here, 400 here. They're consistently in the same space. So using context clues, this must be the position where the status codes are being saved. So with that information in mind, let's see if we can make some modifications to our previous commands to get to the right answer. So this might get a little bit funky. I'm going to assume, actually, I don't need to assume. So these columns, if we just say they're all space separated, URLs aren't allowed to have spaces in them. If there's actually like a space, it gets converted into a %20. That's additional context that which might be useful for you, but for the purposes of doing this, it just it just helps us understand that if we use spaces to split out this data, that won't be a problem to get this field. Because in theory, if there were spaces in the URL, then we might need different columns for different rows, right? Because if there was a space here for say, then now to get this field, we need to go one column further, right? Or if there were two spaces in here, then we now need to go two further. So it wouldn't be the same. It wouldn't be the same for every single line if there were spaces in the URL, because that would mess it up. And so what I'm going to do is I'm just going to go back and I'm going to delete this. And I think we're still going to, I think we can still use the space. And so what I'll do is I'll just change the column. So 1 is the IP address. 2 should just be that dashed line, this dashed line. 3 should be the second dashed line. There it is. 4 should be the timestamp. There's a timestamp, and all the timestamps have a space after them, and then followed by this looks like a time zone offset. So this is 4 hours behind UTC, the universal time. If you're, I mean, you're probably familiar with just time zones in general, like East Coast, typically you're -4, -5. And then on the West Coast, you're typically -8 and 7. That's the same thing here. So let's just go further. That will grab us the time zone. Number 6 will get us. So what this is doing is it's getting us the portion where it prints out the command that was, so you could like a get command in HTTP is like to retrieve a page. There's also like a post command, which will send data to the server. It's getting into a little bit of the weeds here. We don't need to know that, but let's just go and see if we can get to the status codes. Okay, so this is not consistent. You can see here when we did the 7 and we did the 8. So 7 is getting, this is the status code, but these are URLs. So it's not, so this is a problem. So that strategy is not going to work. What I'm going to do instead is actually, I'm going to split on the quotation, because the quotation, we're looking for data that's in between the two quotations. And so if we just split on the quotation and we get what's in between these, so we're gonna have, sorry, we have 2 quotations here, and we're just gonna get what's after the quotation, because there shouldn't be more than 2 quotations in front of the data that we want. So I'm gonna get the quotations, and then let's just try this out. F1. Okay, so that's getting us everything up until this first quote. So that all the way to the end of the timestamp. And then the second one should give us everything in between the quotations for the request for the page. And so there it is, get the slash. So let's just get the home page. Someone's trying to get robots.txt, someone's trying to get something on the admin panel. And this data looks rather consistent. There were several ones where the requests were empty. And so you can see here, this is like an empty request. And so all of his data is consistent. That's kind of all I'm checking for right now. And then we go to the third one. So now this is everything after the second quote, before the third quote. I don't know if the third quote is consistent, but I know that immediately following the second quote is the data that we want. And so I'm not actually too worried about it as long as as long as there isn't a third quote in front of the status code, we should be fine. So we have all this data and it looks pretty consistent. Yep, it's definitely consistent that we get basically two columns, which are two numbers. And the left number is the status code. And I'm pretty sure the right number is going to be like the file size of the, sorry, not the file size, it's still the size, it's the size of the response that's being sent back. And so what we can do is we can actually send this to another cut command. Cut, and then I'm going to cut on space, because that's consistent again. And then if I do the first field, I think that will, only one typo list may be specified. Oh, sorry, this is a typo. So if you recall previously, we had this space in front. So this is actually getting like this empty section before the space, which we don't want. What we actually want is the second one, the second column. And there's the second column. And then like previously, what we can do is we can just put this through a sort. So it sorts it again, and then we can put it through unique. Now unique is nice because there's an option for unique, the -C option, which actually gives you the frequency count of how many times that value was seen. And so if I do unique -C, I can see, oh, 200 commands showed up 19 times, 301 2 times, 400 came up 38 times, 404 21, etc. And so we actually got the next two questions in one shot with this one command. So we have 19 that had a 200 status, and then with the 400 we have 38. And so we're making good progress. Then now we have what IP address rang at the doorbell. This is a little bit like of a, it's not a straightforward question. Like you're probably like, what the heck does this mean? And so what I would recommend doing is trying to search around and try to figure out like, is there anything in here that matches, whatever this rang at the doorbell is. So I'm just gonna search for like rang at the doorbell, nothing, or rang at the doorbell, nothing matches. And then you just shorten your search. No, doorbell, rang, doorbell, nothing. Okay. What about if we just like look through here and see if there's anything that might look suspicious or look like it might be relevant to that? And I'm really, oh, actually right here. Ringing at your doorbell. Is there anything else that says ringing? Nothing else that says ringing. All right. We're gonna guess this one. Context clues. It's the only thing that's relevant. It seems relevant. All right, we got it. And so that's kind of like, there's like no specific like, steps for you to go and do this. This is just like, okay, we're being asked what rang at the doorbell, and I'm just gonna be looking around here for like anything that seems to be relevant or pertinent to what that question asked me. Now we're being asked what version of Googlebot visited the website. And so I would definitely recommend searching for Google. That would be a great starting point. And so we can see Google Fav icon. That's there. What other things? Okay, that's a search. Google bot. Okay, so there's a Google bot. Let me change to searching for Google bot. 2.1, 2.1, 2.1, 2.1. Looks like it's pretty consistently 2.1. So what if I just copy and paste that? All right, we got that answer. So again, using kind of context clues and treating it like a treasure hunt, a scavenger hunt. I need to find a Google bot. Let me search for Google. Then subsequently we search for Google bot. This looks like a version number. Let me just copy and paste it and see if that works. We're now here on this question. What IP address attempted to exploit the ShellShock vulnerability? And for the sake of just doing this, I'm going to search for ShellShock. So there's no shell. Is there a shock? No shock either. If you can't find anything immediately here, the next obvious step would be to Google around, or not necessarily Google, but you can use any other search engine to see if you can get any additional context that will help you. And so if I search for ShellShock vulnerability, this was pretty big a couple of years ago. And you can see it's got its own Wikipedia page, which must mean that it's important. And there's all of this information here. And so there are some of these like little things here that will kind of indicate to you that there's a vulnerability. And so what if I just search for this type of stuff? So let me just search for like it seems like I'll just start searching for like this. Let me see if I can find anything there. Nothing there. What if I, oh, something matched. What matched? Oh, okay, this matched. Hey, that looks kind of similar to this. Yeah, it looks very similar. And then this says bash, and this also says bash. Yeah, it's pretty similar. I think the only difference is that there's like an extra space. There's an extra space over here. Okay, so we're gonna guess this. Actually, what was the question? Which IP? Okay, yeah. So this is the IP address that attempted. And we're correct, right? So basically, like if you're thinking about this in context of like you're working on a job, you're an analyst, an alarm got triggered, or like you're just like proactively looking at the logs trying to figure out whether something is wrong. If you just say, if you, for example, like an alert goes off that says, hey, vulnerability triggered, vulnerability detected, and you go look at these logs, and then the error message or the notification says, oh, ShellShock, you can go and Google it and you can read about, oh, how does ShellShock work? But more importantly, you can come here and you can say, oh, at this specific time, this IP address ran an attempt to exploit ShellShock on our website. And you can see like exactly what the command was. So it looks like what they're trying to do here is they're trying to start up bin bash. So bash is the shell for the terminal. They're trying to delete everything in the temp folder. They're trying to download something from this IP address, and that they're calling Java. That doesn't necessarily mean it's the Java software. It's called Java, and then they're saving it to the temp folder, and then they're printing out by China Z into this program, and then they're making the program executable, yada yada yada. And then it's doing another download. So this looks like it's trying to download malware onto a computer. And so now you've basically practiced what it's like to be, a small snippet of what it's like to be an analyst is like, hey, I got an alert. I need to go process this alert. Let me go look at the logs. It says something about ShellShock. Let me go research ShellShock. Okay, let me search for something that looks like this. We found something that looks like this, and then we could do further analysis and understand that even more. And you just get a little bit of a snippet of that, but it's amazing how much you can do without too many sophisticated tools, right? This is a Linux command line. We try to provide it to you when we can, but you can also download Kali Linux, and we definitely recommend that you download Kali Linux and get your own set of tools. But we didn't do anything fancy, right? I mean, we ran a series of commands that all we did was we printed out a file and we selected certain columns, and then we figured out how many times they showed up. But this is very useful if like, you're getting a lot of reports that, hey, the website's got a lot of errors. If you get a lot of 400 or 404 errors, you can go count how big of a problem is it, and then you can subsequently go and say, well, let me go and look at everything that had a 400 error or 404 error and see if there are any common pages that people are visiting that are triggering those errors. And so there's a lot of cool things that you can do just by like searching online for some additional context, by using normal searches, within the data, and by just doing some small manipulations with the data using the Linux command line. Just just that combination of tools, like using the internet for search, using basic searches within your text, and using the Linux command line to process that data, you can solve a lot of different challenges just with that. And right now we're coming up on time. And so I just want to check, I think we went through a lot of different concepts in this past hour. Does anyone have any kind of lingering or final questions?
I think that was perfect, Franz.
All right. Well, I appreciate everyone for joining us today, and then we'll try to make these recordings available to share with the students as well.
Yeah, thank you, Franz. It was excellent, especially the Wireshark piece. I gotta say, the Wireshark, going through the cap file. Thank you.
Yeah, of course.
All right.
Right.
Well, with that, it's a wrap, and we appreciate everybody's time. So thanks so much, Franz.
Take care. Have a great weekend.
Bye.
Bye.